one of the most important skill in organic chemistry is drawing an arrow, right? The curved arrow that you saw in the resonance structures. Yeah, just like those arrows, okay? So we use the curved arrow right here to represent the delocalization of a lone pair, right? With the movement of the lone pair. I'll give you some example here. So I'll look down here. This is an acid-base reaction. Water will act like a base, and the hydrochloric acid will act as an acid, okay? So what's going on here? So like overall, you're gonna see that this proton here moved to bond with water, right? So you get hydronium ion instead, okay? Now we can use the curved arrow to represent this reaction. So we're gonna start with the base. Water is gonna use one of the lone pair from bond with this hydrogen. Okay, this process we call deprotonation. So water deprotonate hydrochloric acid. All right. All right. So this is from bond. Now, if you still remember that hydrogen is on the first period in the periodic table, can have up to only 2 electrons. That's a 2 electron. That's a maximum electrons that hydrogen can get, right? Can receive. Now, so hydrogen want to form new bond with the oxygen with the 2 electrons there. So they have to give up these 2 electrons with the chlorine. So we're going to use the curved arrow to represent the 2 electrons movement up to chlorine. Like that, right? That's why if you look at the product, so chlorine have 1, 2, 3, 4 lone pairs from 3 lone pairs, right? The 2 extra electrons right here, the red one, come from the bond with the hydrogen. Okay, and if you notice that the 2 lone pairs of water in hydronium ion, it got one lone pair left because the other lone pair is used to form bond with hydrogen. Okay? So we use the curved arrow to represent the electron, a lone pair movement, right? Not an atom movement. Okay. All right. So a bit more detail here. So number 1 right here represent the bond formation between oxygen and the hydrogen of hydrochloric acid. That's a bond forming right there, the 2 electrons. And number 2 right here show represent bond breaking between hydrochloric acid and a proton. Okay, and please do not do this. It's tempting to do this. Many people who didn't do well in organic chemistry in the past, they can't overcome this. I mean, but you gotta get this down. Okay, this is really important. So do not do this. It's tempting to use the curved arrow to show that proton hop up to water, right? Because it look just like that. But no, we use electrons to represent what? The movement of the lone pair, right? Not an atom movement. You can't. If you do that, you can't explain it. For example, how does this bond break? There's nothing to show that bond is broken, right? You might as well just leave chlorine like that. I mean, I don't know how to explain that, right? And another one, if you draw the curved arrow like this, how do you explain that bond right there? Where does that bond come from? It doesn't make any sense, right? 2 lone pairs here. Now, why one is disappear? Shouldn't we just leave it like that? I mean, nothing makes sense there. Okay. So again, this is very important. We use the curved arrow to show electron movement, not an atom movement. Do not do that. All right. If you keep doing this, like you're gonna have a problem with this course and organic chemistry too. All right. So make sure you know that. This is really important. All right. Curved arrow show electron movement, not an atom movement. Nope. Don't do that. Okay. All right. Clear that up already. Let's try this on your own. Okay. So I'll do the first one for you, and you do the B and C. All right. In A, who's an acid? So we have acetic acid here of vinegar, right? An acid lose proton, right? And ammonia accept the proton, become ammonium ion. All right. So ammonia gonna use these 2 lone pair, attack hydrogen, right? Form bond with the hydrogen, and the hydrogens wanna take 2 more electrons. Have to give up 2 electrons right here and goes to oxygen. Ta-da! Right there, and you get that product there. All right. Let's try to on your own B and C, and then you check with me. Okay. In B we have water. That's your base, and we have nitric acid. The red proton right there. That's an acid. Okay. So water we form bond with the hydrogen. We'll use one of the lone pairs. From bond with the hydrogen attack. We call attack. Right. Attack hydrogen, and the 2 lone pair right here. Not 2 lone pairs, sorry. 2 electrons in the bond break, go up to oxygen. You should get a nitrate ion with the oxygen with 3 lone pair from 2. This is 2 lone pairs, right? Become 3 lone pair. Get an extra lone pair from the bond. And water become hydronium ion. 2 lone pair become only 1 lone pair because 1 lone pair is used to form bond with the hydrogen. Okay. Now C, come down here. All right, this is sulfuric acid and water. So water accept proton. Right, so attack proton, from bond with proton, and the electrons in the red bond goes to oxygen. So this oxygen from 2 lone pairs become 3 lone pairs. Okay, and hydronium ion right here. The water become hydronium ion, and then another water comes in. We have another proton. You might have heard we call sulfuric acid as a diprotic acid, which means they can dissociate twice. This is the first time. This is next one is second time. Okay, another proton right here. Water attack. And 2 electrons in the bond, the blue bond here, goes to oxygen. So this oxygen will end up with 3 lone pairs. Okay, all right. That's one of the most important skill for this chapter. So keep in mind, right? Always remember that the curved arrow is used to represent electron movement, not an atom movement. Okay.